So we have a lot of developments in military. Military is one of our largest segments within the industrial space. Some of the key developments where we are introducing, enabling and innovative technology around the areas of very high-speed converters. Converters is a big focus for us at Analog Devices. We have over, we're close to, in fact, 50% market share with our converter business today. It's really a key investment focus for us, and bringing out enabling technology that can really deliver value to our customers is important. So that one of the latest developments where the military customers can adopt this technology is on the gigasample per second converter space. These are extremely fast, very wide bandwidth converters. Products like the AD9625, which is a 2.5 gigasample per second capable product, really delivers value to customers in electronic warfare, in radar and in communications applications within military and aerospace. Now the thing you need to bear in mind about these converters is they don't work on their own. It's a solution play. So the beauty of that is that Analog Devices has other precision components that can go around the converter to basically deliver a high-speed solution. And these converters actually can offer capability from direct RF-IF conversion capability. There's high levels of integration on these devices, so as well as being a very high-speed, wide bandwidth converter, they also have additional integrated digital functionality incorporated on the chip, like digital down conversion as well. So that's one area, where we're bringing some differentiation with new technology into the military space. The other area is communications. We have already a wide portfolio of high-performance RF products that are used in the RF signal chain. And recently, over a year or so ago now, we've introduced a highly integrated, agile RF transceiver that really integrates a lot of the RF, or most of the RF signal chain into one highly integrated solution that can be used in really applications like communications systems, software-defined radio, for example, and again bring value to customers in terms of not only a higher integration of the signal chain, so reducing the bill of materials, but also higher performance and lower power consumption. And as I mentioned, having the ability to do agile communications, very fast switching of between frequencies is really a challenge that is facing our customers in secure communication applications, for example. Other areas that we have within the military space are highly integrated solutions around motion. So we have a range of products, the inertial measurement units, and these devices are system-in-package solutions that really incorporate a complete signal chain around a sensor or a number of sensors to measure movement in any particular plane, whether that's acceleration, whether that's rotation, whether that's tilt, whether that's vibration. These parts really offer a complete plug-and-play solution. So these devices actually have the front-end sensors, so whether that's an accelerometer, a gyro, a magnetometer, or a pressure sensor, and the analog and digital signal processing around these devices to basically provide a fully calibrated plug-and-play solution for motion measurement, combination of acceleration, rotation, or just in one particular plane. And we have devices that can offer 10 degrees of freedom now available at Analog Devices. So those are sort of three areas, that we're bringing value to customers with differentiation, today.
And just to add to it, the three technologies that John talked about, we are finding fantastic acceptance of these technologies out in the Indian defense market as well, be it for software-defined radio with a highly integrated AD9361 part, right, which is a single chip, wideband, ultra-wideband transceiver chip, be it with the IMUs, the initial MEMS units, which are more getting used for dead reckoning, right, or for initial measurements, for be it autopilots in UAVs, or for if you lose track of GPS, making sure that your position sensing is still correct, right? And the third aspect is the high-speed converters, the several GSPS converter technology that is finding ways into the radar piece out in India. So these are the three aspects.
And I think the other, the trends that these address in these solutions address in the industry in general, from military and defence perspective, are size, weight, and power. SWaP. This is a well-known, let's say even a challenge within the industry to our customers in making higher performance units in smaller size, that weigh less and consume less power. So SWaP is a major driver in this space today, where we at Analog Devices are developing solutions that really help our customers deliver their technology out to the market at, as I say, smaller size, lesser weight, and lower power consumption, while still maintaining high levels of performance. I think that in general in the market, I guess some of the barriers to growth are really, one fundamental one about customers really understanding how to use this technology and how to design with this technology. And we have, at Analog Devices, we have a group of systems applications engineers attached to each of the segment application spaces that really understand some of these challenges and understand what customers need to do to really, address and solve some of the problems that they're facing today in their designs. So to us, it's not only just about delivering technology, it's about delivering a service to our customers to enable them to be able to use and get the maximum use out of this technology that we're delivering to the marketplace. And I would see that as almost a barrier at our customers, because we are noticing that there's fewer and fewer good analog design engineers out in the industry today, and that's an area of concern for us, being an analog and signal processing supplier. And being able to provide expertise and competence in the solution space really delivers value to our customers in this respect. Communications market from a military perspective, I mean, you need to consider there's different requirements within commercial communications and military communications. Secure communications and having the ability to really protect communications in a secure nature is really a key requirement, a requisite within the military communication space. Not so much so necessarily in the commercial world. I think the other one is coming back to this size, weight, and power thing. We have to offer very high levels of integration in our communications devices to enable customers to build their communications devices in small units as well. If you consider the soldier in a battlefield environment, one of the key needs today is for these people to be able to move around quickly, but also be able to communicate quickly as well. This isn't really necessarily the case in the commercial world. We all have our mobile phones, and we can sit in the chair quite comfortably and make a conversation. You have to consider in a battlefield environment that situation isn't realistic. These guys are often in hostile conditions. They're in very inaccessible places, and they have to be able to communicate very quickly, very securely, without giving their locations away. So being able to deliver a technology like, as we were talking, the RF transceiver integrated solution that enables the secure, helps enable the secure communications is really important. The other thing is size. We can't have large communications. If you remember, previously in the past, you watch the old war films and things, these guys are there with these huge, great big boxes out on the war field with these, telephone systems and everything. Now it's much more of a handheld, very small size form factor device that needs to have all that integrated in it. So all this big box is now in this small handheld thing. which makes it a lot easier for the soldiers, but it makes it more challenging for the designers. And coming back again to having this systems competence within the within analog devices segment structure to enable our customers or help the customers to design these solutions using this new state-of-the-art technology is really important to delivering a complete package to the customers, together with the software support services as well that go with it, of course.
Yeah, if you shift over to the India angle from a communications standpoint, it was majorly the handheld radios, voice-centric, right? But that's where we see a revamp happening, be it in the Air Force, Navy, or on the military side of things, right? Where the voice will eventually go over and do data, right? High-speed data, secure data. So I think that those are the communication pieces, and as we mentioned, the single chip transceiver solution with a very extreme wide band of 70 megahertz running up to 6 gigahertz and so forth. These are the technologies I see. We are not just finding acceptance of this globally, we are finding acceptance now in India as well. There's more and more electronics in the electronic warfare. In fighter planes and helicopters, more and more electronics are going. So the content of electronics widely varies based on what kind of procurement you're talking about. If you're buying a large ship in that capex, the amount of electronics would be much smaller. But on the tune of any fighter plane would be how much? Upwards of, each fighter plane would have upwards of close to $250,000 to $500,000 of electronics.
I think
these days.
I think absolutely. You know, I mean, the fly-by-wire systems are really being adopted. You know, in the aircraft industry at a phenomenal rate. So, you know, again, you're looking at really, to some extent, taking some of the technology that's being used in fighter planes and really now taking those into commercial airliners, where, you know, we're really reducing the weight of the wiring and the harnessing by taking that out and really putting in electronics closer to the sensor units, to the signal processing blocks. So there's more of a distributed digital communication type architecture rather than having the classical analog communications and signals flowing through, you know, lots of cables and such like. I mean, military aircraft, you know, use a phenomenal amount of electronics, you know, they have radar systems, you know, more complex radar systems on their, you know, electronic warfare systems, you know, missile control systems, as well as the classic engine control systems, you know, comfort control systems, you know, pilot control systems and things like that. So yes, I mean, I think content is very high. It's difficult to put a particular number on it. And obviously it depends on the you know, the plane or the end application
as well.
But it is growing at a phenomenal rate. And